From Mufassal alleys to the glittering highways, today's India is striving towards a better tomorrow. Today's India is in the making. The foundation and structure on which this rising India stands should not only be strong, but also pocket-friendly. It should be designed to meet the specific needs of the country. Through history, there has been a constant evolution in the materials used for construction, from wood to stone to concrete. Though concrete in some form or the other has been used since the ancient times, reinforced concrete, as we know it today, was invented in the year 1849 by Joseph Monet. Since then, there was no looking back, and even today it is the building material of choice. However, this material comes with its drawbacks that need to be addressed. Concrete is heavy, and construction using it takes time. It also has an adverse effect on the environment. It causes damage to the fertile topsoil, can lead to soil erosion, water pollution and flooding. This underscores the need to move beyond concrete and stone to develop alternative construction materials that are strong, lightweight and environment friendly. They should be able to withstand the ravages of natural disasters like earthquakes and cause minimum damage to life and property. With its varied topography, culture and climates, there are many indigenous construction materials that address all these issues. Take for instance the state of Assam. In Assam, most homes are constructed using bamboo and mud. The walls are made of bamboo strips and then plastered with mud. The houses are detailed out to combat the heavy monsoons that slash across the state. The use of bamboo also has other advantages. It is abundantly available in the state, is affordable and is lightweight. It minimizes destruction in the event of an earthquake. Scientists in India are drawing upon the traditional knowledge systems to standardize them, strengthen them and make them accessible to all. They are taking inspiration from the architecture of Lawrence Baker. As far back as in the 1960s, he was a pioneer in sustainable as well as organic architecture. Taking the lead in this initiative is the CSIR Structural Engineering Research Center in Chennai. The scientists at CSIR SERC are designing, analyzing and testing structures to give shape to the country's landscapes.
We are committed to sharpen our focus on the high science-based futuristic technology development as well as to be in the forefront of serving society and industry through innovative solutions by fostering multidisciplinary approach to research in the thrust areas of structural health monitoring, disaster mitigation, advanced materials for sustainable structures and multifunctional structures.
For many in the country, affordable housing is still a dream. Expanding urban slums and people living on the streets remind us of another important mission in nation building: affordable housing for all. An increase in seismic activity across the globe has rendered millions homeless. To give life to the dream of owning a home and to mitigate the damage caused by natural calamities, scientists have developed a construction material that is lightweight, affordable and has the ability to withstand earthquakes. This wonder material is the precast lightweight wall and roof panels. These lightweight panels consist of two reinforced concrete skins with expanded polystyrene or EPS as a core material. This EPS is reinforced with a wire mesh in 3D directions. The wire mesh prevents polystyrene core shifting and greatly increases the panel strength. Nearly 2/3 of the panel thickness is replaced by EPS. This reduces about 67% of weight of the structure without compromising its structural integrity. The use of self-compacting concrete for outer skin makes for faster casting and greater quality control. The performance of these panels is evaluated for flexural, axial and seismic actions. They have undergone a series of stringent tests to ensure their durability as well as test their ability to withstand seismic activity.
We have further gone for developing into bigger size of room size, that is 3 meter by 3 meter, and this panel has been assembled over the shake table, and that has been studied for seismic force. We have gone with the 0.5 G forces, and we could see only the superficial cracks only at the openings. Otherwise the building is much strong enough to withstand the earthquake forces.
The EPS panels have a host of advantages that make them the ideal construction solution. They not only make walls and roofs stronger, but also help build them faster. They will help the government meet the demands of housing through quick and quality constructions. These houses, nestled in the mountains at Dharmashala in Himachal Pradesh, are a testimony to this. Having low thermal conductivity, they can remain cool in summers and warm in winters. The panels are resistant to corrosion and can sustain in all kinds of atmospheric conditions. This makes them especially suited for India, a country whose climate is as diverse as its culture. The advantages of the EPS panels also extend to the environment. They lead to pollution-free construction, and the wastage of materials is minimized as compared to construction using conventional methods. The panels also use industrial waste in huge quantities. This results in sustainability of construction material. An offshoot of the lightweight EPS panels are the two-tip toilets. With the launch of the Swachh Bharat Abhiyan, there has been a sustained drive to make an open defecation-free India. Even in this day and age, people are bereft of toilets, especially in rural areas. This affects their dignity and leaves them vulnerable to disease. The need of the hour is affordable toilets that do not take up too much space and are easy to install. To address this need, scientists have developed the special toilet unit using thin precast concrete segmental panels. These panels can be joined one above the other with perfect bonding and through connecting rods. The septic tank can also be built using these thin precast panels. One unit can be made ready to use in just 3 hours' time without using any special equipment. They have been designed for durability and can withstand any climatic condition. The two-tip toilets present many advantages. The construction uses industrial waste, and so it is eco-friendly. The panels are cost-effective, lightweight and durable, making them easy to transport. This means the all-weather toilets can be easily installed even in far-flung areas. And most importantly, one unit costs only 12,000 rupees, making it eminently affordable. Open defecation-free India is now not just a vision, but also a reality that is taking shape.
To meet the Swachh Bharat mission at the Csir-Serc, we developed two-tip technology. Two-tip is nothing but thin concrete segmental panels that will be very lightweight in nature, and it is cost effective and highly durable. The main objective of this technology developed at the SERC is to bring down the cost, and also the panel which can be easily transportable from one place to other place and can be assembled within 2 to 3 hours by use of 3 peoples.
Bricks, stone, mortar. Till today, they have been the backbone of all construction, but they have an adverse impact on the environment. That has been a concern to scientists worldwide. Use of brick results in greater CO2 emissions, right from their manufacturing to their transportation. The need today is for a sustainable construction material that mitigates the negative impact of construction on the environment. Another drawback of masonry structures is their vulnerability to earthquakes. 75% of fatalities attributed to earthquake are caused by collapse of buildings. Out of these, About 70 to 80% are due to the collapse of masonry buildings. There is a staggering demand for strengthening methods to improve the structural performance of masonry structures to resist the seismic loads. To address these issues, scientists have developed a building material lighter than concrete, yet just as strong, if not stronger. They have developed the innovative textile reinforced concrete, or the TRC, that is set to revolutionize the construction industry. It is a composite building material with textile or fabric embedded in a cementitious binding matrix. It has undergone a series of stringent tests to emerge as a strong, durable alternative construction material of the future.
Compressive strength of textile reinforced concrete mainly depends upon the compressive strength of the binder. So we have to determine what is the maximum compressive load the binder can take. So we are doing compression tests by testing the cubes. We have used a material testing system which is software controlled to determine the compressive strength of the binder, and that is taken as the design parameter in the design of textile reinforced concrete component. This is one of the typical glass textile what we used for textile reinforced concrete developments. This is polyacrylic coated, and we have to determine the maximum tensile strength, maximum elongation ability and the failure pattern of this textile.
This test is on uniaxial test on TRC concrete specimen. It is subjected to uniaxial tension. When there is uniaxial tension, the stress state is uniform throughout the specimen. When it is loaded in the uniaxial direction, many multiple cracks will occur due to the layers, and these multiple cracks are very advantageous for the structure, and the meaning of multiple cracks is the energy absorption and ductility of the member, and this will be very much useful for the earthquake regions where the energy absorption expected is very high.
This is the test setup for flexural strength testing. Like uniaxial testing, this flexural strength testing also gives the tensile property of tensile reinforced concrete, but indirectly. It actually evaluates the ability of this textile reinforced concrete to withstand failure in bending.
TRC has proved itself to be versatile and has been used in a number of interventions. TRC panels can be used for a number of exterior and interior applications.
The technology I am going to explain is a TRC wall panel system, which consists of a TRC skin and a profile sheet. The two systems consist of one single wall panel system and is connected by a spacer system, which one slides over the another. The idea is to join two panel system by this spacer so that the gap is found in the center of the wall. This gap can be used for damp proofing. It can also act as insulation against extreme weathers and also as acoustic barrier. The central portion can also use for taking the services such as fire line and water line and fire hydrant.
The TRC panel structures are not just useful, they can also be aesthetically pleasing. Among their many advantages, one is that they can be custom made to any shape and size without using molds. The TRC material can be used not only for buildings, but also in street furniture, manholes, flower pots, etc. The panels do not require heavy machinery for mass production. Not only are they cheaper, they also take less time in manufacturing. Even unskilled laborers can manufacture it. India has applied for global patent of this technology. Producing TRC panels at large scale has the potential to revolutionize the way we look at our infrastructure.
For rural and urban developments, we have developed load-bearing as well as non-load-bearing panels that can be used for wall construction, roof construction, and for boundary walls, then temporary shelters, security cabins, and so on. It has vast potential for its application in various segments. This material has all the potential to be considered as a candidate for building New India.
TRC panels have established their mark at the global level as an alternate construction material. Now, they have the potential to help shape India's landscape. Scientists have developed toilets using TRC panels and are contributing further to achieving the vision of an open defecation-free India. The TRC toilets have many advantages. They are lightweight, non-corrosive and durable. The TRC toilets are also more affordable than conventional toilets. A toilet can be assembled in just 3 to 4 hours by 2 persons using simple tools. The lifespan of these toilets is 25 to 30 years. Innovations in textile reinforced concrete also have the potential of saving lives. This is manifested in the TRC crash barriers that are being developed at CSIR-SERC. These crash barriers can at times be the difference between life and death in cases of road accidents. They are capable of resisting impact forces, easy to install, replace or repair, elastically deformable and so cause less damage to vehicles and passengers, have better performance than conventional barriers, and are adaptable for use in narrower spaces.
When a vehicle impacts on this crash barrier system, the force exerted by this crash barrier system is getting dispersed to the adjacent crash barriers by using this side anchorage mechanism. Simultaneously, the force gets dispersed to the ground using the base anchorage mechanism.
The impact of the TRC crash barrier systems can be felt on many levels. For the road and transport sector, they are a new product that has mass application both nationally and internationally. For the road users, they contribute towards improving quality of life by making roads safer. They minimize damages to vehicles and severity of injuries. They even have a positive environmental impact. They have no harmful substances, are co-efficient, and there is an absence of corrosion. These crash barrier systems align with the government's Make in India initiative by opening up new avenues for large-scale application of technical textiles.
There are 3 types of barrier, for example, as per the classifications of Indian Roads Congress. It is called like low containment, normal containment and high containment. Low containment is the one which has been used at many places, and high containment is the one which is used at hazardous places or in extremely difficult situations. Our design is for low containment, and it can be easily extended for other categories of high or normal containment.
Construction touches every aspect of life, and so do the new construction materials that are being developed. One such aspect is electricity. Even as the government is expanding the reach of electricity, the question of unhindered power supply remains.
The tower in our village fell, so there was no electricity for 4 weeks. My children had to study in candlelight.
Like this village, there are many others that suffer due to long power cuts. In a country as vast and geographically diverse as India, ensuring uninterrupted power supply is no mean task. There are times when natural disasters cause collapse of transmission line or TL towers. This interrupts the power transmission. If these collapses are not attended to well within the time, it leads to huge monetary losses as well as loss of service to the customers. Statistics tell the story of losses incurred by the nation owing to inefficient power supply. Conventional methods of power restoration take as many as 3 to 4 weeks. To address these problems, the CSIR-SERC scientists have developed a simple yet effective solution. The Affordable and Convenient Emergency Restoration Service, or ERS technology, can reduce the time for resumption of power supply after a transmission line is damaged. The developed system has been designed using FE software and has been proof tested for the prototypes of the structures. All the elements have been tested as per international standards, ensuring that the system is structurally stable.
By using this system, there are ready-made modular structures available which we have to transport to the site, and within 2 to 3 days we can be able to restore the power. The system is easy to plan and use. Though this system is compact, yet it is affordable. We have used the lightweight material for the fabrication of this system so that it is helping us to use it at remote locations. Third thing is, this system is so flexible that we can develop any configuration of transmission lines, whether it is single circuit, double circuit towers, or the lines from 33 kV to 800 kV transmission lines. We can develop any transmission line tower by using this modular system.
ERS is a lightweight, temporary structure that can hold the transmission line in place of damaged poles. It is easy to use and its lightweight makes it possible to be carried to all kinds of locations. It can easily be installed in all soil types and assembled in a short span of time. The state electricity boards as well as distribution companies can cut their losses while consumers get their right of uninterrupted supply. The ERS makes every stakeholder a winner. Shorter durations of outage means people will have to use lesser fossil fuels, thus saving the environment. The ERS technology has the potential of hope of a new prosperity for people from the Himalayas to Kanyakumari. If industries and dams are modern temples, then scientists toiling at labs like Csir-Serc are no less than seekers. They seek welfare for all, and such path-breaking technologies are the fruits of their labor. They have all but one mantra: science as the building blocks of development.